Good evening, everyone. Welcome to the second webinar in the Spring 2025 series presented by Newton Conservators. My name's Beth Wilkinson, and I'll be the moderator of this virtual event. Barbara Bates is our wonderful technical director, as usual. Newton Conservators is an all-volunteer nonprofit established in 1961. We are grateful for the beauty and sustenance that the land provides for humans and the other creatures with whom we share the earth. Our goals of preserving open space and connecting people to nature require challenging the ways in which land conservation has historically excluded some peoples from protected land. Newton Conservators commits to acknowledging this exclusionary history and to building active partnerships with groups who've been hurt by that history, starting but not ending with Indigenous peoples such as the Massachusetts. As naturalist Aldo Leopold wrote, "When we see land as a community to which we belong, we may begin to use it with love and respect." Tonight, we are so fortunate to have experts Jennifer Forman Orth and Doug Bidlack about mosquito biology, the real science about what you can do to avoid getting mosquito bites, and how state mosquito control helps prevent exposure to mosquitoes and mosquito-borne illness. Jennifer is an environmental biologist for the Massachusetts Department of Agricultural Resources, where her work covers entomological and botanical issues. She completed her Ph.D. at UMass Boston. She also has a master's degree from Boston University Center for Energy and Environmental Studies. Doug is the entomologist at East Middlesex Mosquito Control Project, based in Waltham. He received his Ph.D. from Clemson University while studying black flies. We are so incredibly fortunate to have them here to educate us tonight. We're going to first say welcome and hear from Jennifer. Take it away, Jennifer.
Okay, great. I'm going to jump right in because we have a lot to cover tonight. Thank you so much for inviting Doug and I here tonight to talk to everybody. For my portion of the talk, I'm going to cover the mosquito life cycle and disease transmission cycles. I'm going to do a review of statewide mosquito control efforts and then talk to you about how to protect yourself from mosquitoes and hopefully convince you why you should do it. First of all, why are we concerned about mosquitoes? Two main reasons, right? Mosquitoes are a nuisance and mosquitoes can carry disease. In terms of them being a nuisance, mosquito bites are often painful. They can certainly be very itchy. High levels of mosquito activity can make people just not want to be out in their backyards. They often will avoid recreational areas when mosquito activity gets high enough. And sometimes you'll see an impact to tourism. So there's an economic impact associated with mosquito activity as well. But also mosquitoes can carry disease. We call these diseases arboviruses. That's short for arthropod-borne viruses. Things like in Massachusetts, West Nile virus and Eastern equine encephalitis. And then on more of like a national and international level, things like dengue fever, chikungunya virus, and Zika virus. So before we talk about like the mosquito disease cycle, I just wanted to briefly go over the life cycle of a mosquito. Mosquitoes are flies. The flies are in order Diptera, and like all flies, they go through a life cycle where they lay eggs. The eggs hatch into larvae. The larvae pupate and transform into the adult. But what's different for mosquitoes versus most other flies is that before the female can lay eggs, she needs to take what we call a blood meal. So the feeding of mosquitoes on humans and other animals is actually required to give them the nutrients and energy they need to lay eggs. Once a female mosquito has taken a blood meal and is ready to lay eggs, she will, depending on the species, lay like single eggs or sometimes a whole formation of eggs called an egg raft. And these will be laid either directly on water or sometimes in moist soil that's prone to flooding. The eggs will hatch, depending on the time of year and the species, anywhere from, a few days in peak heat of the summer to maybe a week or more in cooler parts of the spring or fall. And what hatches looks sort of like a worm-like larva. These are aquatic larvae. They live under the water. They breathe oxygen from a tube at their posterior that they raise to the surface of the water, but they live their life in the water. They feed on things like algae and detritus, although some mosquitoes are carnivorous and will actually eat other insects. But they will live under the water, depending on the time of year. Again, they will go through several different like life stages where they grow and shed their skin. We call them instars. And after the fourth instar, they will eventually pupate. So this is like with a butterfly, it goes from a caterpillar into the chrysalis and then metamorphosizes and emerges as a butterfly, except it's going from a sort of a worm-like larva into an adult mosquito. And any of these stages, so the larval stage or the pupal stage, will be sped up by the time of year. So if the temperatures are warmer, then it might go through the larval stage in 4 to 5 days and then the pupal stage in another 4 to 5 days. But this will take longer if temperatures are cooler, and then some species will overwinter as larva or pupa. Once the mosquito emerges from the pupal case, it takes flight into the air and lives the rest of its adult life on land, not aquatic. Okay. So we have now records for more than 54 different mosquito species in Massachusetts. Compare that to like worldwide, I think there's like 3,500 different species. So we have just a small percentage of those in Massachusetts. And I know this slide is a lot, right? I just wanted to put this whole list here so you got a sense of like all the different diverse mosquito diversity that we have in Massachusetts. And this is everything from the perturbans, which Doug is going to be talking about in a lot more detail, where the larvae bite into the cattails and other submerged aquatic plants. Sorry, I'm missing the word in my brain. But anyway, they feed off of the underwater roots of cattails and breathe through them. They breathe oxygen through the plants. These are big nuisance species in our state, but they also carry disease. And then you have something like a fairly rare insect, Wyomia smithii, a mosquito species that lives its entire larval life inside the pitcher of a pitcher plant. It even, as it gets cold, winter temperatures, it freezes in a block of ice inside the pitcher and overwinters that way. Those are not nuisance species. You're rarely even going to see one. They don't impact humans at all. It's just kind of a neat way of showing mosquito diversity. But just to kind of get into the thick of things here, I annotated the list that was in the previous slide. And first of all, the species that are in a bigger font and they're bolded, these are the species of concern for mosquito disease control in Massachusetts. It's about 20 species. So less than half of all the species we have in Massachusetts are of concern from a mosquito control perspective. And then I added these little emojis. So basically what you can take away from this is the more emojis next to a species, the more concerned you should be about it. And there's a few different emojis. So the mosquito emoji is showing the nuisance level. The more mosquitoes next to a species, the more of a nuisance it is. And by nuisance, I mean it's purposely going out of its way to bite humans, and it's aggressive. But also the neutral face emoji, the little smiley there, is next to any species that is spreading disease to humans. And then the animal emoji next to some of those species are mosquitoes that spread disease from animal to animal, but not to humans. So a couple of things I want to mention about this slide. One is that a lot of people separate nuisance species from vector or disease carrying mosquito species. But at least in Massachusetts, there's an extreme amount of overlap. If you look at any of the species here with a lot of mosquito emojis next to them, almost every single one of them also carries disease to humans and to other animals. And the ones that don't, and they have like question marks, it's just because we don't know. It's not that they don't carry disease, it's just that we haven't been able to prove it for whatever reason. For example, something like oculoctatus japonica in the top right corner. It's a rather new introduction from Asia to America that is becoming fairly common here in Massachusetts, and they just don't know whether it has the ability to spread the diseases that mosquitoes carry in Massachusetts. The other thing I want to point out is trademark Psilocybin melanura, not a nuisance species. It rarely, if ever, bites humans, but we care about it a lot because it helps drive the Eastern equine encephalitis disease cycle. And I'm going to talk more about that in a few more slides. I'm going to talk to you about the two main mosquito-borne illnesses that we are concerned about in Massachusetts. First of all, West Nile virus. It was found in Africa in the 1930s and accidentally brought here in infected mosquitoes in the late 1990s when it was first found in New York. Symptoms of West Nile virus include things like fever, headache, body aches, skin rash. About 20% of people infected with West Nile virus only show mild symptoms. So you might not even realize you have West Nile virus. You might just feel sick for a while, mild symptoms, and then just be fine. But about 1% of the people infected with West Nile virus go on to develop what we call neuroinvasive symptoms, things like limb paralysis, high fever, tremors, and sometimes, unfortunately, this leads to death. Over time, researchers have found that outbreaks of West Nile virus are becoming more frequent and the severity of illness has increased. So there seems to be more cases of neuroinvasive West Nile virus than there used to be, and they're not sure why. The other thing that's interesting about this disease is that outbreaks of West Nile virus are often associated with drought conditions. I think that's counterintuitive for a lot of folks because you would think, well, if there's more water, then there's going to be more mosquitoes and then there's going to be more West Nile virus. But actually, what they think is happening is that when there's less water, that birds and other animals that are the source for West Nile virus when mosquitoes bite them, they tend to congregate in a more constricted area because they're finding like whatever small water source is available to drink the water they need to survive. And so it creates this really dense area where there's lots of virus and lots of mosquitoes biting, and then that leads to more human cases as well. So what drives the West Nile virus transmission cycle in our state is this relationship between mosquitoes and birds that are carrying the virus. This is mainly Culex species, and Dave's going to be talking more about that. But birds can deal with a large amount of virus in their system and not die from it. Whereas if a person or like a horse or a deer gets West Nile virus, they need a very small percentage of that virus in their blood before they're going to get really sick. In fact, humans and horses and deer are actually called dead end hosts because if a mosquito bites a human, they don't pick up enough of the West Nile virus in their blood to effectively pass that on if they bite another host on the line. Whereas birds will continue to amplify the amount of West Nile virus in their blood and then in the mosquitoes that are feeding on them over the course of the season. I'm going to skip over this slide because I know Doug is going to cover it better than me, but I will say that West Nile virus tends to be spread around primarily by Culex species. Now, Eastern equine encephalitis was discovered actually in Massachusetts, but way back in the 1830s. Symptoms are somewhat similar to West Nile virus. They include things like fever, headache, sometimes more extreme things like vomiting and diarrhea, and eventually convulsions and unfortunately coma. And 1/3 of all people infected with triple E die. And those who survive often have severely impacted lives. May have brain damage, and it's just difficult for them to survive after they've contracted the disease, even if they do survive. So it's a much more impactful virus than West Nile virus for these reasons. Outbreaks of triple E tend to be cyclical, so you'll have high levels of triple E within the mosquito population for 1 to 2 years, followed by little to no activity, sometimes for 4 years or more. what drives the triple E transmission cycle in our state is fairly similar. There's a mosquito relationship with birds, and then the mosquitoes are spreading it to mammals from the birds. But it's a little bit different. First of all, the mosquito, again, I mentioned before, Culicida melanura, it's primarily a bird biter. It rarely, if ever, bites mammals, including humans, but it has strong relationship with birds. So the birds become what we call the amplifying host. The levels of virus of triple E in their blood rise over the course of the summer. As the mosquitoes keep biting them, they're picking up more and more virus. And then we have a second mosquito species, primarily Cuculatidia perturbans, but there are other species involved that are what we call a bridge vector. So they are carrying the virus from birds into mammals like humans and horses and deer. I'm going to skip this one too because I know Doug's got some good slides about Culicina melanura and Cuculatidia perturbans. Okay, so what is Massachusetts doing at the state level to deal with mosquitoes and the arborvirus that they're carrying? I'm going to talk about state-based mosquito control, local options, and then what you could be doing both for personal protection and habitat management. But first, got to go through all the bureaucratic stuff. Um, State level, we have the State Reclamation and Mosquito Control Board, mosquito control districts or projects, and then the Department of Public Health. The State Reclamation and Mosquito Control Board oversees mosquito control for the state. It's made up of a 3-member board, the chair of which is in my agency, the Department of Agricultural Resources. And then we have someone from the Department of Conservation and Recreation and someone from the Department of Environmental Protection. The State Reclamation and Mosquito Control Board works, well, not only with mosquito control districts that it oversees, but also with the Department of Public Health and with sister agencies, sometimes like the Department of Fish and Game, and sometimes with this outside mosquito control experts we call MAG, the Mosquito Advisory Group, when they're determining whether there's some kind of a response needed in response to a public health emergency. And that might include like aerial adulticiding to kill mosquitoes because there's a disease outbreak. And when I say adulticiding, it's a short way of saying that we're going to use a pesticide to target specifically adult mosquitoes to kill them. State Reclamation and Mosquito Control Board has all these different administrative and technical policies, and they have management guidelines to ensure that we're doing safe and effective mosquito control. They also appoint all the commissioners of the mosquito control districts. There's a link to learn more. Beth has assured me that we're going to send out a list to everyone that registered with all the links. So if you can't grab this off the screen now, don't worry about it. We'll make sure you get an email with all of those things so you can get more information. This is more what happens when we do need to respond to a disease outbreak. It coincidentally just happened this past year in 2024 with Eastern equine encephalitis. This is a map. First of all, the orangey color, and I'll point with my mouth in case you're colorblind, is showing the risk levels elevated in certain parts of the state for Eastern equine encephalitis. And then you have the bigger circles are in that area, the more cases of mosquitoes testing positive for triple E. And then you have both animal and human cases marked by those icons on the map. I think the first thing you'll notice is that we have this hotspot, and honestly, we've had this issue for decades in Smith County and adjacent Bristol County area, so down in the southeast, where we have lots of Culicida melanura habitat that drives the triple E cycle in this area. But more and more frequently, we're seeing outbreaks in the central and western part of the state. In 2024, it was specifically in southern Worcester County. Later in the season, we started to see activity in Middlesex County in the Metro West area, and also in Essex County up in the northeastern part of the state. But levels of virus were strong enough in the Plymouth County area and also in the southern Worcester County area. State, upon discussing, the SRB in consultation with Department of Public Health and the Mosquito Advisory Group determined that it would make sense to respond to the mosquito disease levels to try to staunch the outbreak and reduce the number of human cases. So this is a map showing you where they did the operations in August of 2024. I do have a link for this too. I left it off the page, but I will make sure you have it in the email so that you could explore these maps further if you're interested. We did an aerial spraying of adulticide in the Plymouth and Bristol County area, and then we did truck spraying in southern Worcester County. The area in Plymouth County, a well-known high target area that has been under mosquito control for a really long time. Folks are used to us having to come in every year and do the aerial spraying. We determined that it made more sense to do a truck-based spraying in southern Worcester County. None of those towns are in a mosquito control district, and we weren't sure what their comfort level would be with an aerial spray, and we didn't have a lot of time to be able to act in an efficacious way. So and it would make more sense to send around to spray what we could spray along the road to try to reduce the virus. So, I mean, that's what happens in an emergency situation. But what's really going on, every year, day to day during the mosquito season is on the ground mosquito control operations are happening at the level of the mosquito control districts and projects, not the state reclamation board. They're the ones doing surveillance of mosquito larvae, surveillance and trapping of adult mosquitoes, treatment of both larval and adult mosquitoes, water management to remove mosquito habitat, and of course, source reduction. The best example of that is removal of abandoned tires, which are perfect larval habitat for mosquitoes. And the Department of Public Health obviously plays a really strong role in mosquito control and testing and surveillance in Massachusetts. We're the ones receiving samples from the mosquito control districts and doing the molecular testing for arborvirus. They also do supplemental trappings, particularly in areas that aren't represented by mosquito control districts. They have long-term trap monitoring set up so they can track over decades levels of Culicida melanura and triple E and other issues of interest for mosquito control purposes. And they're the ones doing the majority of communication, the public, the MCDs, to the boards of health. I mean, the mosquito control districts definitely do some of this too, but when there's a disease outbreak, you tend to hear more from PH. Also working directly with the CDC to look at sort of diseases from a national perspective, and also to look at things like pesticide resistance in mosquitoes. This is a map showing the current mosquito control projects and districts across the state. Right now, we have 11 different mosquito control districts. The newest one is in Pioneer Valley, so that's over in Franklin, Hampshire, and Hampton County. Here, you guys are in Newton, you are in the East Middlesex Mosquito Control Project, which is the pale turquoise there. And just to give you a sense of how much work is going on every year, mainly being done by the mosquito control districts. Last year, there were almost 1 million mosquitoes collected as part of state surveillance. The majority of these were picked by the mosquito control districts. The rest were captured by traps set by the Department of Public Health. More than 250,000 of these were then tested for mosquito-borne illness. So there's a lot of work going on during the mosquito season that folks maybe don't see. But what we have to do to monitor for signs of disease in the state. Also, mostly during the off season when mosquitoes aren't active, the mosquito control districts are doing a lot of habitat management over, well, almost 1 million feet of habitat was managed for the purposes of mosquito control. Things like cleaning out ditches and culverts and opening up salt marsh areas to improve the flow and reduce stagnant water and mosquito habitat and things like that. So if your town isn't in a mosquito control district, and you don't have the options that I just discussed, then towns can still do something if they perceive a mosquito control district. Some of them will hire external contractors to do testing or to do larviciding. And of course, if you're concerned about mosquitoes on your property and you're either not in a district or you're not able to get services from the district, then people hire private companies to do mosquito control as well. I mean, this is only a small part of mosquito control within the state, and it tends to be more focused on the nuisance that mosquitoes are causing and isn't really about mosquito control. Municipalities can also work with their boards of health to declare a like a public hazard if they think that there's a severe mosquito issue in their town and they're not being serviced by a mosquito control district. But maybe this is the more important part of my talk. I mean, the emergency operations we do, they're sporadic and they're fairly unpredictable. And they're never going to get rid of all the mosquitoes or all the disease. So no matter what we're doing at the state level, it is still really important for the public to practice personal protection. And that means paying attention to the type of clothing they're wearing, the repellents they have on, and their general behavior, especially when we're in the middle of a mosquito-borne disease outbreak. First of all, your clothing. You've probably heard this before from DPH. If possible, when there's mosquitoes and you're outside, you should be wearing long sleeves and pants. And also, that clothing should be very loose fitting. If you're wearing something like Lycra and it's really tight against your body, or you're wearing something with like a really loose weave, then the mosquitoes are going to be able to bite through your clothing. So you really need it to be like loose and long. And you also should really be keeping your ankles and feet covered. There are certain mosquito species in Massachusetts that preferentially are ankle biters. You know that you're going to be in mosquito habitat for a long time. You might just consider wearing or purchasing netting. Like I have a whole mesh jacket that I wear that covers my entire head and hands that the air can flow through, but the mosquitoes can't bite through. Is it ideal in August with high humidity? No, it's awful. But I know that I'm not going to get bit by a mosquito. I am going to be sweating a lot though. Your options for your clothing, you can get clothing that's been pre-treated with a product like permethrin. It's a synthetic pyrethroid. It's used as a repellent and an insecticide. It has the bonus ability to repel and kill ticks, which I find to be really handy out in the field. I actually have a set of gaiters that are Velcro and wrap around my calves, that also repel mosquitoes at the same time. You can buy permethrin and treat your own clothing, or you can even use a service where you mail your clothes out and they'll treat your own clothes that you well, and then send it back to you. And you can even wash the clothing and the permethrin will last for a long time. Just a note though, keep cats away from treated articles until they're dry. If you have cats, you're going to want to just be extra cautious to not be spraying permethrin when they're around. You got to let the product dry out. Now, permethrin clothing's not going to work for everybody for various reasons. And also, I get it. Like when we tell people wear long sleeves and it's like August in Massachusetts, or maybe don't wear flip-flops when you're outside. I get that doesn't work for some people. So another option is definitely to use repellent. Typically you apply it to your skin, although some of them are for clothing. And I'm talking about repellents with active ingredients like DEET, picaridin, IR3535, or oil of lemon eucalyptus. And when I say oil of lemon eucalyptus, I mean this is eucalyptus oil that smells like lemon. It's a type of eucalyptus. It doesn't have lemons in it, and it's not related to lemongrass. And I'll talk about why that's important in another couple of slides. But just to convince you more that these are the active ingredients you want in your repellent. He did a scientific study to show when you apply different types of repellent, like how good is it right when you apply it and how good is it 4 hours later. And basically, the stuff that's colored in here has the skinniest, shortest rectangle is the best for you. And at the top is product that contains DEET. It is only 25% DEET. To note that I think a lot of times people think, well, the more of the active ingredient in there, the better it is. But the more DEET, having more DEET in a product doesn't change how good it is at repelling mosquitoes. It only changes how long it lasts. So if you know you're going out for a walk and you're only going to be out for an hour, you do not need to apply a product with 98% DEET. 25% DEET is totally fine. You'll notice that after 4 hours, there's still only 29% of mosquitoes attracted. And another thing, look, oil of lemon eucalyptus is actually a really effective mosquito repellent. Not everyone can use it. Honestly, I can't wear it if it makes me feel like my skin is burning off, but if it works for you, it's a good natural alternative to some of the other products. I kind of like the way it smells. I just can't use it. A lot of people don't like the way DEET smells. You might want to switch to a product that has like keratin in it, because that doesn't smell as bad as DEET. Also, I just want to note this Victoria's Secret perfume, for whatever reason, is fairly effective at repelling mosquitoes right when it's applied, but that wears off pretty fast. So what doesn't work with repellents is, unfortunately, a lot of the products that are listed as natural. So if it doesn't have oil of lemon eucalyptus in it, it's probably not going to work. Lemongrass, citronella, soybean oil, peppermint oil, rosemary oil, all of them have been shown to not be effective repelling mosquitoes. And I know everyone's got a story about concoction that they've made that they spray on themselves that works. And I think some of that stuff is really effective right when you apply it, and then it fades really fast. Also, those mosquito bracelets that are sometimes advertised as being good repellents, they have not been proven to work. That meme that was going around social media, that live plants, if you just plant lemongrass and citronella outside on your porch, and the mosquitoes will be repelled, that doesn't work. I mean, using something, harvesting the oil from something and using it is going to be in a much higher concentration than just whatever's inside a plant that's next to you. It doesn't repel the mosquitoes. Also, those fan clips that blow the pesticide, typically metafluthrin, that you can like wear, clip to your clothes or whatever, they have very limited effectiveness. They don't create a full barrier over your entire body. They're really just going to be effective right when they're clipped. So again, I'm going to make sure you have this link for the EPA search tool for repellents. It will ask you a bunch of questions about what kind of product you're looking for, what's important to you, and then recommend, again, an EPA approved repellent that actually will work for you. Some other things to think about with personal protection is just your behavior. Like, what are you doing certain times of day? What's the weather like? Are you paying attention to that? Are you paying attention to what the season is, right? So most people know that mosquitoes are typically most active at dawn and at dusk. There are some species that are day biters, but in general, when mosquito-borne disease is high, then you'll start to hear warnings to like limit your activity at dawn and dusk. Or if you have to be outside, then make sure you're wearing repellent and long sleeves and things like that. Also, if you're in an area that has salt marshes, tidal cycles will drive mosquito activity. You know, when the tide gets really high, it will flood areas and then create stagnant water, and you might get a mosquito outbreak a week or so after that. So pay attention to that too. If you're in a mosquito control district, they're probably already paying attention to that for you, and even larviciding, but it's still something to keep in mind. Also, as the temperature goes down, mosquito activity decreases. Once temperature is under like 55 or so, you don't have to really be that concerned when you're outside. Although, on the other hand, when days are really overcast, sometimes you're going to see more activity because it feels to the mosquitoes more like dusk or dawn. And also, anytime there's a rain or a flood event, that can often lead to a burst of mosquitoes that are specifically floodwater species. So it's basically eggs that might be there for several seasons until the area finally floods, and then all this mosquitoes will hatch. Things like Aedes vectans is a good example of that. Also, keep in mind there are certain mosquitoes that are active at different times of the year. There are like spring broods, and there are mosquitoes that are more common in the summer. The main mosquito-borne illnesses in Massachusetts typically ramp up in late summer or fall. That doesn't mean you don't need to protect yourself in spring. it just tends to become more important, especially in outbreak years in the late summer or fall when there's a lot more virus around. Also, pay attention to things like damper, shady locations where mosquitoes are more active, salt marshes, swamps, river habitats, especially after they flood, and any area with a large amount of debris, especially if the area is wet or it has used tires or other container habitats. West Nile virus tends to be more linked to urban areas and catch basins, especially when they get filled with debris. Triple E tends to be linked more to swamps. I know Doug's going to talk more about that. On your own property, one thing you should be doing is identifying potential larval mosquito habitat and then doing something about it when you can. That includes everything from standing water in ditches and puddles to flooded areas, retention ponds, cattail marshes, woodland pools, swamps, wet leaves, and debris. Although I do want to say that what I'm going to talk about makes more sense for you in like artificial containers. If you have property that has wetlands that have cattail marshes and things like that, then that area is under the jurisdiction of your town's conservation commission, even if you own the property. So don't be doing any mosquito management in natural wetland areas without first getting permission from your conservation commission. And honestly, they're not likely to give permission except under really specific situations, typically ones that involve the mosquito control project as well. So what you can do with artificial containers is kind of scout for places where stagnant water is pooling, because that stagnant water is going to become larval mosquito habitat. Things like equipment or machinery, old tires, bird baths, kiddie pools, unused plant pots, abandoned swimming pools. Here's a few pictures of habitat. I have a feeling Doug's got pictures of this too. I always get my friends to send these into me every year so that I can put them on social media. Um, Tell people to dump things out once a week if you can. So any mosquito larvae that are in there will get dumped and die before they become adults. You can do that with a bird bath. You can't do that with a swimming pool, right? So tip or drain any standing water when you can. If you can't, then is it something where you can maybe drill a hole in it so that the water drains, or scoop it out, or even treat it? Clear gutters of leaves and debris, because leaves and debris mixed with water makes perfect stinky water for mosquitoes. They love to lay eggs in that. If you see something like an abandoned swimming pool on an abandoned property, have tens of thousands of Culex larvae in it. If you see something like that, please either report it to your mosquito control district or to your town's board of health so that they can follow up. You should consider whether any artificial container with water should be treated with larvicide, especially when draining is not an option. Products with BTI, it's a bacteria that they call it a biological. It's very low impact. It basically it will affect mosquitoes, black flies, and very few other species. The mosquitoes ingest the bacteria, it makes them stop eating, and then they just die. That could work in a bird bath or sometimes in like a rain barrel or something like that. That's not an option. Another thing to consider is aerating or agitating the water. That might also work for a small bird bath, right? If you could put a pump in there or something. Keeping the water from becoming stagnant will significantly reduce the chances that mosquitoes will lay eggs in. And then just a quick note, bats are super cute, but they do not really perform mosquito control. So I saw another meme going around on social media. They change the number every year. It's like one bat will eat 600 mosquitoes per hour, or one bat now it eats 1,200 mosquitoes per hour. The truth is, this is based on a study where they stuck a bat in a box where they only had mosquitoes to eat. So yeah, of course, that's the mosquitoes. They ate a lot of mosquitoes because they had to eat something. In reality, bats eat a wide variety of insects, and they do not preferentially eat mosquitoes. Mosquitoes are like all leg and a little tiny body. A bat would much rather eat like a nice moth if it can get its mouth on that. And just a final note about personal protection, make sure that you're including checking the resources that are available to you. You're going to hear a lot more from Doug about what it's like to be living in a mosquito control district and the services that are being provided. A lot of MCDs keep their towns and cities up to date on mosquito activity, or if there's a disease outbreak, or any treatments planned and things like that. So it's important to kind of bookmark things and follow people when you need to. Also, definitely, I'm going to make sure you have this link, EPA website. You need to bookmark that. They have an arborvirus update. They keep up from the entire mosquito season from June until October. They have maps where they show risk levels for West Nile virus and triple E, and they show every mosquito that tests positive and every human and animal case that they find out about is on that site. So, I mean, I use this site almost every day during the summer, and I think it would be useful for you folks to keep an eye on it. Just a couple of quick lessons. You heard about how the state is working to assess and manage mosquitoes and mosquito-borne illness in the state, but outbreaks are still going to happen from time to time. So you need to stay informed about disease risk, use that information to make smart choices about when and how to be outdoors. Please protect yourself when you know you're going to encounter mosquitoes, and avoid critical risk areas when possible, especially at the time of day when mosquitoes are more active, when you know that there's a disease risk. Also, when you can, reduce the larval habitat around your home by dumping out sources of standing water, or preventing water from collecting in the first place, or treating it if that's an option. All right, that's it for me. I'm going to pass the mic over to Doug.
So I'm going to be talking about mosquitoes as well. I'm going to go into a little bit more detail about specifically about Newton in the East Middlesex mosquito control area, so that you have some idea of what's going on in your neighborhood. Um, First of all, what we do exactly as far as collecting mosquitoes to find out whether we have West Nile virus or Eastern equine encephalitis, we use two major collection devices, traps. On the right side here, you have a light trap, which we've been using since 1984 to collect mosquitoes. And this basically gives us an all-around picture of what the mosquitoes that are out there. It's using dry ice in that box, that green box. It sublimates into CO2, the gas, and it's heavier than air, so it goes down below, and that's what mosquitoes are attracted to. And then they're attracted to a small light there, and there's a fan that pulls them into the net. And so that's run by a battery. And we take those and we throw them in the freezer, kill them that way, and then identify them, and then send any that might have triple E, and this is mainly for triple E, if we're going to look for disease, and then send them to Department of Public Health, and they'll see if they have triple E. The other one on the left-hand side here, we've only been using that since 2000, and that's because of West Nile virus, which we didn't get until about 2000 area. It came into New York City around 99, ended up in our area about a year later, just barely. 2001 was really the big year it took off. And this is specifically used to catch Culex mosquitoes, which are the ones that transmit the virus within the bird population and also from birds to humans. And so it's called a gravity trap because it's specifically collecting Culex mosquitoes that are ready to lay their eggs. So that means they've already had a blood meal. And if they've already had a blood meal, there's a much higher probability that they're going to have, well, a much higher probability that they'll have disease, because they can't pick up disease before they take a blood meal, because the disease, West Nile virus, cannot be transmitted from the female to her offspring. Nowadays, since about 2018, I've been testing slightly different trap, CDC trap style. The trap itself is the same. It's just the CO2. Instead of using dry ice, we're using compressed air, compressed CO2 in a tank. And this way it doles out the CO2, meters it out over the entire nighttime very evenly, instead of all coming out kind of early on in the evening. And especially the hotter the evening is, the more of it will come out really early on. And so that leads to some issues, and we're not sure that we're getting as good idea of what's actually happening out there. And I had to do this for 3 years, so we have a good comparison between this CO2 source and the old one, so that I knew how to compare them, so that I wasn't using all that old data that we had. We could still use it. So I'm first going to talk about West Nile virus, and this is the mosquito, one of the mosquitoes that's transmitting West Nile virus. It's Culex pipiens, and it's very closely related to Culex restruans, so much so that we tend to lump them together as one taxon, and we just call them Culex pipiens slash restruans because they're so hard to tell apart, and they're both involved in transmission of West Nile virus in birds, and probably also to humans, although Culex pipiens is much more likely to bite humans than Culex restruans. Kind of a plain-looking mosquito, no striping on the legs or the proboscis, and it's kind of a light beige color. A lot going on there. The larvae, as Jen mentioned, tend to be in urban and suburban habitats. So they basically like humans. We provide plenty of containers for them to live in, the larvae, such as this upturned trash can that has organic material in there from the leaves and other debris that gets caught in there. And that's exactly where the larvae like to be. The female chooses those places because they're really great places for the larvae to live, and she'll lay their eggs there. Other places would be like catch basins, and as you mentioned before, Jen did, about all the other little containers you can have, gutters and so forth, catch basins and that kind of thing. Now, this is a multi-bolting species, both of them are, which means they have several generations in a year. It looks kind of like there's just one generation because it's just one peak and it goes down. There's actually multiple generations, and it just happens to peak during this really warm time of the year, right in the middle of the season when it's really the hottest, basically. And last year we had a little bit less than we normally do, but not by a lot. So this just shows where West Nile virus is in the United States, the incidence. And this is based on, it's not total number of people with neuroinvasive disease. It's basically a proportion. So there might be a lot fewer people getting it in, say, North and South Dakota, but because there's so few people that actually live there, the incidence is much higher. And the reason it's so much higher in the middle of the country is that they actually have different species of Culex that are more efficient at are more likely to bite humans, so they're more efficient in transferring the virus to humans from birds. And we don't have those Culex species, so that's a good thing. So we have had West Nile virus since 2001, our disease anyway, when our first year we had it. Past year, 2024, was one of our heavier years as far as human disease is concerned. We had 18 humans with the disease. Our worst year was 2018, where we had nearly 50 human cases. And as Jen mentioned, also, this tends to be worse during hot, dry years, which seems counterintuitive. It's kind of the exact opposite of triple E, which you'll see later on. So hot, dry years tend to have a lot of West Nile virus. This past year was a really weird year. It was kind of like 2012, where it was kind of really warm and wet early in the year, and then really hot and dry in the second part of the year. So it was a weird year because we had a lot of Eastern equine encephalitis and a lot of West Nile virus. It's just that the triple E tended to occur earlier in the year and then tailed off, and West Nile virus kind of went the opposite direction. Okay, so this shows kind of where West Nile virus is most prevalent in our state by county, and it's mainly in the Boston metro area, so Suffolk County and Middlesex County, especially the part of Middlesex County that's close to Boston. And this shows a little bit better. It shows our district, East Middlesex Mosquito Control, and you can see the hotspots are very close to Boston, and in particular, Brookline was number one as far as this is positive West Nile virus mosquito pools. Newton is number two, and the mosquito pool it's not one mosquito that's tested. We tend to put mosquitoes in pools up to 50. So each pool will have anywhere from 5 to 50 mosquitoes. If we only have 5 mosquitoes collected in a gravitrap, or excuse me, 4, we won't send them in. If it hits 5, then we'll send in a pool of 5. If we have 60, we'll have a pool of 50 and then a pool of 10. So we'll have 2 pools, but it won't be any more than 50 ever in a pool. So that gives you some idea of where the disease is most prevalent. Winchester is just very low because we only sent in samples back in very early years, 2000, 2001, 2002, and they haven't wanted to collect any information since then, so we haven't. And that's why it's a 0, not because it doesn't occur there. Now let's go on to triple E. Um, that disease is transmitted within the bird population by Culicida melanura. And in a way, it looks a little bit like Culex mosquitoes. They're kind of plain looking. They don't have banding on the legs or the proboscis. Um, but they're a significantly larger mosquito. They're much darker. And I tend to think that they're more elegant looking, I would say, more attractive, kind of like the cedar waxwing of a bird. They look very nice. It also has a very long and curved proboscis right here. So that's a mosquito. And this mosquito, the larvae live in a very different habitat than Culex mosquitoes, at least pipiens and rescuans. This is an Atlantic white cedar swamp. And unlike Culex, which like to have very organically polluted waters, these tend to have like waters exactly the opposite. Very clean, very acidic water with a lot of sphagnum moss, and it means it's very acidic. And they're not going to be, the larvae aren't going to be in these pool areas, these open pools, which you might think. They're actually found right here underneath these little areas, these mounds around each of the trees, around each Atlantic white cedar. And these are, the area under here actually has a little bit of air in there. And then it is, the root ball is in there, and it kind of almost walls off this little wet area from the rest of the wetland. So it's almost like a container within the wetland. And it's in these areas where these larvae occur. The females are able to find small holes in these little dry areas, get in there, lay their eggs, and knows that this is a great place for the larvae to live. The larvae do not like light. If they're in the open area like this, they will try really hard to find a dark place. They really don't like light areas, and they will spend their time underneath these areas. And these areas are known as crypts, actually, these areas underneath the trees. So they're very hard to treat, and it's actually kind of very difficult to control the larval stage because of this. They're kind of almost cordoned off from the rest of the wetland. If you put something in the wetland here, like BTI, I'll mention that later, it's not going to work. It won't control them. This is our second favorite place in Massachusetts overall. It's a red maple swamp. It looks somewhat similar in that you have these trees on these hummocks with the open wetland areas. There are also crypts underneath these trees. They're not usually as good or as big. And they're also not as good. This wetland type is just not as good as an Atlantic white cedar swamp. And it's because they dry out much more readily. And the reason this is important for Culicida melanura is that it's an unusual mosquito and that they overwinter in the larval stage, which is quite rare. It's the rarest way for mosquitoes to overwinter in Massachusetts. So they're very susceptible to drying down. And an area that dries down, especially towards the end of the year, like in fall, late summer into fall and into winter, if it dries down, they're just going to die. The larvae will die, and they will get completely wiped out in a habitat like this. And red maple swamps tend to dry down more readily than Atlantic white cedar swamps. So Atlantic white cedar swamps tend to act as refugia during drier years, where they can still survive in those small areas. And then when it gets wetter, when we have multiple wet years in a row, it will move out into other areas like red maple swamps. So we knew we were going to have a bad problem with Culicida melanura in 2024 because the population was going up in 2023, and it was wet. 2023 was very wet, and the beginning of this past year was also very wet. So we knew we'd have a problem, and we did. 2024 was our highest Culicida melanura population that we've ever had since 1984. So that mosquito doesn't bite people, uh, or it has been shown to bite people, but it's extremely rare, and it's not going to drive disease in humans, basically. So in order for the triple E to get from birds to humans, it needs another mosquito, a bridge vector, as Jen mentioned. And the best bridge vector in our region is this species right here, Cochlearctidae perturbans, which looks very different. Instead of looking very elegant and neat, it looks very messy and kind of salt and pepper looking. It's got striped legs, it's kind of a striped proboscis. Right here you can see it's kind of very, very indistinct. So the light part has a lot of dark parts in it. The dark part has a lot of light parts in it, so we call it like a salt and pepper mosquito. So it looks that way. It looks very grizzled. This mosquito has yet another habitat type. Instead of forested wetlands, like Atlantic white cedar swamps or red maple swamps, this species likes to exist in marshes. Cattail marshes are probably their favorite habitat overall. Um, you don't have as many of those here in Massachusetts as they do in some places farther to the west, like in the north central states. And so it's called the cattail mosquito. That's a common name for it. But in our region, they're actually just as common or even more common in mixed marshy areas that have maybe cattails, maybe some Phragmites, and also maybe some shrub, the shrub swamp. And as Jen also mentioned, these larvae are very unusual in that the siphons they use to breathe with are sharp at the very ends, and they can use them to dig into, penetrate into the roots of these plants, and they can breathe through these plants, basically. And it's a way for them to hide in the mud down below in the roots and not be eaten by predators. Because, again, this species, like Culicida melanura, again, it's very weird. Culicida melanura and Coquetidae perturbans, they both overwinter as larvae, which is a really weird strategy. And it just happens that two species that we care most about happen to overwinter in the same way. So that very wet years, a lot of them together help both of these species out, and they just happen to be the two that are important in driving eastern equine encephalitis in the bird population and then passing them on into mammals. So this is a way for them to get away from predators. Basically, is to get in the mud and stay out of sight from, there could be fish in some areas, or there could be, more likely, it's larger invertebrates like dragonfly larvae, which are more likely to be in more permanent wetlands. So this is the univolting species. I didn't mention that Culicida melanura actually is bivolting. It has 2 generations in a year, always. Coquetidae perturbans has 1 generation per year, and it peaks typically right around the 4th of July, which is a pretty rough time. That's just when it's really warm and people are getting out. And so this is what makes them a dangerous mosquito. They're our most common mosquito. They love to bite birds and people and other mammals. They're extremely abundant, and they live a long time, which makes them really dangerous. They're much more likely to be able to pass disease onto you or some other organism because they live a long time and more likely to bite more animals. And so they're more likely to be infected with a disease. And so this past year, we had our highest population ever of this species. And because we've been getting warmer and wetter due to climate change, it's been driving this species, in particular some other ones as well, into higher populations. So unlike West Nile virus, where we're kind of almost a non-factor compared to the rest of the country, it's exactly the opposite with Eastern equine encephalitis. Only Florida has had more human cases since 1964, and we only have a little over 7 million people here in Massachusetts. They have more than 3 times that many people in Florida, I think over 23 million people. So the incidence rate is much higher here in Massachusetts. So it was first kind of recorded here in Massachusetts from the late 30s when they finally knew that it was distributed or vectored by mosquitoes. And that's our first records of it. And it was our highest. We had 35 human cases back then. I think it's 38, 39. And so as Jen mentioned, they're usually in 1, 2, or even 3-year cycles, or 1, 2, 3 years together. And then they just kind of peter out. And back in the day, it seemed like it was 10 to 20 years in between times when we'd have outbreaks. Now it's closer to 5 to 10 years, or even just 5 years. And it was happening that the duration between outbreaks was less, and we were getting fewer human cases. Now we still have the durations less, but we're getting to be an uptick in human cases. And actually, in 2019 and 2020, we had 17 human cases, which was second highest ever. Hopefully, we won't have any human cases next year because it got so dry at the end of this 2024 when we had 4 cases. So these are human cases from 1938 until last year. and they're mainly concentrated in the southeastern part of the state. And that's because this is where the Atlantic white cedar swamps are concentrated. And so Culicida melanura is extremely important in driving this whole disease. Even though it's a bird disease and they're mainly biting birds, if it doesn't get high in the bird population, you're just not going to have it spill over into the mammalian population anyway. So you have to have a lot of Culicida melanura. In order for you to have a lot of those, you really need to have a lot of Atlantic white cedar swamps. At least that was the way it was back in the day. Things are changing now with climate change, and we're getting more and more moisture, more and more wet areas. And so that's making red maple swamps more dangerous now because they're more likely to have this mosquito be able to survive. And that's why it's being pushed over to the north into areas that normally wouldn't be able to have this disease, and to the west as well. So Bristol County actually has as much cedar swamp as Plymouth County. As you can see, they don't have as much disease. We think this is because that other mosquito, the one that transmits the disease, Eastern equine encephalitis, from birds to humans, doesn't occur so much in Bristol County because they don't have the habitat there, not very much. They have much more habitat in Plymouth County. And if you look at DPH's cultivated perturbans that become positive with this disease, it's much more common in Plymouth County than in Bristol County. So you have to have both habitats, and both mosquitoes have to be present in order for it to happen. So in our district, and I've included Boston here as well, the gray is areas that don't have mosquito control, so I don't really know what's happening there exactly. And this shows kind of the opposite of what happened with West Nile virus, in that Culicida melanura in our area is mainly present pretty much far away from Boston. It's about as far away as you can get. And this past year, last year, it was most prevalent in Sudbury, Maynard, and Concord, and also North Reading. That's where we had positive triple E mosquitoes. So what can we do to help reduce mosquito numbers? Jen really went through this really well, so I'm going to go through it very briefly. One of the things that we can do is source reduction. And one of the ways we can do source reduction is to keep ditches flowing so that mosquito larvae cannot exist in those areas. They need to have still water. And so if the water's flowing, they're not going to be there. And this oftentimes is only near roads, because road sanding operation during the wintertime, that sand ends up in these ditches, and they end up clogging the ditches up. And so oftentimes this only happens very kind of downstream from the road. Another big source reduction is taking away tires. Jen mentioned this as well. These are really good for larvae. They love these places. Culex mosquitoes do very well in these areas, so that's a problem for West Nile virus. Also, we have an introduced mosquito that does very well here from Asia called Aedes albopictus, also known as the Asian tiger mosquito. You've probably heard of that. And at one time it was thought that it couldn't exist this far north, but it's doing quite well. In part because of tires like this that give them a good, great microhabitat in city areas, and also because it is getting warmer. So how do we control larvae? One of our main things that we do actually is just to treat catch basins, because Culex mosquitoes love catch basins, and Newton in particular has more catch basins than any of our other towns or cities in our district. And so in the summertime, we hire summer help, and they go out and they treat these, mainly with Bacillus sphaericus, which is a bacteria, a living bacteria, which kills the larvae, and the larvae have to be present in order for this to work. So they kill the larva, and then they open them up, and they will infect other larvae. And so it continues throughout, as long as there's water in there, it will continue to cycle through and work very well. The only problem with Bacillus sphaericus is that of our insecticides that we use, it's the one that tends to get mosquitoes can become resistant to it more easily than others. So we have to occasionally switch to methoprene, which is an insect growth regulator. It simulates juvenile hormone, and it keeps the larva in the larval form, so it doesn't become an adult. And it ends up dying in the larval form. In small wetlands, we can go treat by hand with liquid BTI, and BTI is Bacillus thuringiensis, variety israelensis. It was at one time a bacteria. The bacteria is killed after they form spores. Those spores form crystals that are toxic to once the larvae eat them. And so this is something that does not circulate in the mosquito. It's one and done. You spray it on there. They have to eat it, ingest it to kill them, and it does not go into the as a living organism to keep going. BTI, we also use it once a year in April. Typically around the third week of April, we'll do one helicopter treatment of larger wetlands. These are wetlands that are over 3 acres and they're difficult to control by hand. And these are areas that would be close to people that might, or people would be getting bit. And this is, instead of a liquid, this is a granular form because it's heavy and it drops straight down into the wetland. The last thing is adult mosquito control. And we try not to do this because it's the least effective, because wetlands kind of concentrate. We know where the mosquitoes are when they're in the wetland, and we know what mosquitoes would be in those wetlands, so it's easier for us to deal with them. Once they get out of that, they can be anywhere, and that's not ideal. So this is mainly something that happens when we get disease like we had last year in, say, Sudbury, for example. We did quite a bit of spraying in Sudbury because of Eastern equine encephalitis. And this is etofenaprox, and it's spread with a ULV, an ultra low volume sprayer, and that's a synthetic pyrethroid. So it's related to a pyrethroid that's taken from chrysanthemum flowers, except this is a synthetic version of that. I want to say a little bit about new mosquitoes that are moving into our area. This is Aedes albopictus, which I've mentioned before. It's the Asian tiger mosquito. It's quite attractive. It's very easy to recognize because it's black and white and has this nice white stripe that goes down the head, down the thorax, and the palps here are tipped with white. Really attractive mosquito, and they bite typically during the day, which is very unusual for a mosquito. Not many mosquitoes do that. Now, it was thought that this could not exist in Massachusetts, especially as far north as Boston. Obviously, that's not true because it's doing quite well here. Last year was a breakout year for it. We had more than we've ever had by far. In fact, it was the first year that we actually started getting a lot of complaint calls from places like Cambridge, where people were getting bit during the day by this mosquito. And here I just wanted to show a few of the new mosquitoes that we had move into our areas. The first two are not native to North America. They're both Asian species. The first one, Aedes japonicus, is more northern Asian. Aedes albopictus is more southern Asian. That's the tiger mosquito. And this says where they, when they first got to Massachusetts. Aedes japonicus, we found it right away in the Boston metro area. I think I first found it in Brookline, was the first place I found it. Aedes albopictus was first introduced into our state around the New Bedford area. 2009, it didn't get to Boston until 2014. It didn't become a really big problem until the last couple of years, really. This next three mosquitoes are ones that are North American mosquitoes, but had never been found in Massachusetts before. They're all south of us, typically, but they've been moving north because of climate change. Aedes balti moved into our region in 2016, into Massachusetts 2016. The following year, we had it in our area. It's now a very common mosquito. It's found throughout the state now. Aedes atlanticus 21 was the first year in Massachusetts. We don't have it yet. Culex erraticus just last year was the first year we definitely had it. It may have been here a year before that, or maybe even earlier. These last 5 taxa have always been in Massachusetts, but they've been mainly restricted to the southeastern portion or maybe the southern Connecticut River Valley, Pioneer Valley area. But they've expanded quite a bit since then, and we didn't have them. But they've expanded into our region more recently. That's why I just wanted to mention that. And then there are also mosquitoes that we've always had, like Serophopharax, for example, that back in the 80s, we would get maybe 1 in a trap or 2 in a trap. Some years we would get none in the entire year in the 80s, even into the early 90s, I believe. Now we can get thousands in a trap. So even though it's always been here, it's we we get a lot more of them than we used to. And there are some other species that are more northern mosquitoes that have been kind of dropping out. We've been losing them. So that one mosquito I mentioned, Serapha ferox, actually in Norfolk County, they've actually collected as many as, I think, around 25,000 in a single trap, which is just remarkable. So I'm going to go through this very quickly because Jen covered this very, very well. This is what you can do about preventing mosquito bites and therefore keeping from getting any disease as well. And I'm going to go from the doing the easy things that you can do that don't take that much to do, like avoid being outside between dusk and dawn, and particularly during a time when there is a risk of West Nile virus or Triple E. And in Newton, you're not really going to have, I don't think we've ever had any risk for Triple E, to be honest, in Newton. But you're close enough to Sudbury or someplace like that you might go over there, and that could be an issue. But West Nile virus is definitely a problem for Newton, and it's one of our best towns actually in the entire state for West Nile virus. And so you don't want to be running around in the evening, say, especially in particularly August and September without any kind of protection. And one of the ways you can protect yourself is to wear long sleeve shirts, pants, and that kind of. Jen went over this very well. And you can also use repellents. I almost never wear repellents actually, because I usually pay attention to these other things ahead of that, so that I don't typically get bit anyway. Follow all labeled directions, and also you can drain and remove containers from your yard. And this is places like clogged gutters and things like that. And again, Jen covered that very, very well, so I won't go into that too much. This is my contact information. I'll leave that out there for a second. The telephone number there actually directs you to Waltham, Massachusetts, which I'm actually normally in Hyde Park. And so you'd end up getting somebody else and they'll contact me. The best way to get hold of me if you wanted to is to use the email. All right, thanks.
Thank you very much. You gave us so much amazing information and shared your incredible knowledge. It's a little worrisome for us, but no Triple E in our area,
Right.
or little chance of Triple E. So that is wonderful. We have a lot of great questions. I'm going to ask a question. I had say one thing you told us that was so great. I have bird bath. I keep a fountain in it. I do it 2 to 3 times a week. I empty it and refill it. I never thought about my gutters. Now I have to start thinking about my gutters more at that time of year. So thank you. Both of you mentioned that, and it was really helpful. Those of us who live near something like Crystal Lake, though, within a half a block or a block, are we sort of doomed to mosquitoes anyway? Because we live near a place where it's sort of swampy and cattailish at the edges.
Yeah. You're gonna get mosquitoes.
Okay.
I'm not sure I've used the word doomed, but yeah, that's an issue where if you're living in a place that has wetlands near you, and most people do this, right? If they go outside and they're getting bit, they go inside. It's behavior. That's one of the things you can do. I mean, you can put repellent on, but very few people do that. I certainly don't. I actually chose where I live right now based on mosquitoes in part. I knew there weren't very many mosquitoes where I live. So my wife happens to be the entomologist at Plymouth County, and so I live in Plymouth, so I know where to go. Yeah, so the thing is, in Newton and that kind of thing, West Nile virus is the disease you need to be concerned with, and that's going to be a container breeding mosquito. It's not, for the most part. It usually isn't going to be coming from a lake. They can for sure, especially when they dry down and it gets hot. But that's usually not lake. That's usually like small wetlands, and it concentrates the organic material, and that it gets more to their liking basically. And those can end up being, and that's also one of the reasons why we tend to get more culex mosquitoes when it's hot and dry, is because those more natural type areas will become more to their liking, and they become really big breeding grounds for them. And some of our best places are actually along places like farm ponds and that kind of thing that have a lot of they already have a lot of material going in there from whatever the animals that people have at the farm. And then when it gets warm and gunky, it's it just produces enormous numbers, and we'll get big numbers. So those kind of places can, and you can also be backed up near um, a relatively natural wetland, the small ones in particular, that will. But if it's a lake, you're not going to get that many Culex mosquitoes. You're not going to get as many um, if it's unless as opposed to like a pond, because lakes have fish in them, and fish are great mosquito eaters. So
I've read, I care a lot about mosquitoes because I lose blue jays in my yard every year. And one year in August, I lost 11 of them. And I got worried enough that I had the state send 2 of them away. I think they sent them to Michigan, where they tested them, and they did have West Nile. And so I'm extremely careful, but I've read that they can breed in something as small as like a half a cup of water. Is that true?
yeah,
Okay.
it's not many, but
Let's go back to ask some questions. We've got so many questions, but let's ask some about the biology from the beginning. Um, you said that there needs to be a blood meal before, Jen, before they can start to reproduce. Do they have a new blood meal when they're not reproducing, or do they take that blood meal only at reproduction time?
You may correct me on this, but it's my understanding that they take a blood meal before each egg laying incident slash opportunity, and that's the only time they feed on blood. But I'll go ahead and add to that or correct that.
yeah, I think that's good. That's yeah, simpler is better. That's yes, that's right. That they only females and males only need nectar for themselves. The only reason they need blood, the female, is for the young ones, the little ones coming out. That's
Okay,
it. That's
that's
it.
my next question. Perfect. So they eat nectar the rest of the time.
Yeah.
Okay, that's great. The Midwest Culex that you talked about, could it live here if it somehow got transported here?
Uh, I don't know. I'm thinking probably not because I think it has shown up here. Culex teratans. I think it might be one of the ones we're looking for to get it in our collection. I think it hasn't, but yeah, it doesn't really show up here. I think it might have been like Michigan is very rare, and as you go farther west, it gets more common. And that's a species, Culex teratans, that likes to bite people. Um, and it happens to be in agricultural areas, like in Colorado and that kind of thing. And it breeds in ditches that they use for agriculture. So they're putting people and this mosquito right next to each other. So that's why you have a big issue out there. And they like to bite people as well as birds. So it's the perfect vector. You don't need an intermediate um, anything. So it's bad.
You said teratans, right?
Did I say the wrong one?
I don't know.
I
I don't
did.
know. I only know it's on the teratans is on our list, but I don't really see it come up in submissions. So,
Yeah. That is one. Now I can't remember the name of it. Uh,
sorry.
Tarsalis, Culex tarsalis. Thank you. Yeah, Culex tarsalis is the one that's out west. We have teratans here. Um, yeah, you're right.
This is one of our big questions, which is, okay, you know all of the tiny differences between the different species of mosquitoes. We mainly see them maybe when we squash them, if they land on us. But if we were to look at them without being under a magnifying glass, without, using a really strong camera lens, will we be able to tell the difference?
Uh, it's just like any other group of things out there, trees or other plants or anything else. Some of them look very different and some look very similar. Like Culex pipiens, Culex restuans are closely related and they look a lot alike and they're hard for us to tell apart. They're hard for experts to tell apart. So we don't usually. Others look very, very different. Um, so that's hard. It's both. anyone can see the difference between certain species, and even experts have a hard time with other species. And so there's one I had there. I think one of the new ones that we have in our region is Anopheles. It's Anopheles crucians complex, and the reason it's called a complex is because we can't tell them apart. There's a whole bunch of species. Um, there's two fairly obvious ones, I guess you could say. One, the larvae only live in salt water. And so if you catch them kind of in salt marsh areas, you kind of know it's that one, Anopheles bradleyi. But there's five other ones in this other group that are very close related that don't breed in those kind of areas, and you can't tell them apart by looking at them. You have to actually look at them in a molecular way to differentiate them. And there's a guy in Florida who's doing that.
I think I would add to that just that like some species you can determine their identification using just like a photo on your phone, and some of them have the ID characters that separate them are going to be either molecular or perhaps microscopic, so you might need to like key them out. And also if you use any of those online ID tools, like I'm a big fan of iNaturalist.org, you will see a lot of different mosquito species in Massachusetts there. Some of them I think are fairly accurate and some I think are dubious. I think the AI tries really hard to get to species and maybe fails in a few cases. Like I was in there and there were a bunch of records in iNaturalist this week for the southern house mosquito. I forget the Culex species.
Yeah.
I was like, that's not what this is. I had to just remove the IDs and like dispute them. So yes and no, that's the answer.
We'll avoid them all.
Well, no, I mean, there's some that are predators on other mosquitoes. So I don't want to say kill on sight to everything, right? There's some we can appreciate.
Just avoid them. We won't kill them.
Okay.
We have a question. How do you protect your face?
I guess I'll take that and then Doug can add on to it. Two different ways. I mean, one is to cover your face. So a hat will cover the parts of, prevent the parts of your head that are covered by the hat from getting bitten. In serious areas, again, like I said, I have that mesh jacket. It includes a full hood that zips up. So you are completely enclosed by the mesh. That's not practical in a lot of situations. In other situations, then I am using repellent, but I will apply the repellent to my hands and then use my hands to apply the repellent to the parts of my face that I know mosquitoes are going to bite. It's not, you don't want to you keep that stuff out of your eyes because it will burn. But that's what I typically do. Like I know they will sometimes go for like your forehead is usually where I will get bit. And if I have a hat on, then I make sure I have repellent that covers where the seam of the hat is. Because I don't have that with mosquitoes and with black flies. It's like they go right into the seam and bite you there. So you just kind of apply the repellent first and then put the hat on.
We have so many good questions. Does smoke work to repel mosquitoes?
I mean, foggers that have a repellent in them work. I don't think smoke works. Doug?
If you're at a campfire and the smoke is like on you, yeah, you're not gonna, but who wants that? I don't I don't want that. I don't want that. When I'm around a campfire, when that happens, if the mosquitoes are bad, then I might kind of like, but yeah, it's not a good situation. I don't, I don't they used to make something back in the day were called smudges, I believe they were called. Like in Canada, and that where we used to go, and they would use certain plants that they would burn and rub them on you. And it was kind of like a repellent. And they were so, I don't know how well those work, to be honest. I never tried it, so I can't speak to it.
I will say that fans can be a very effective way of keeping mosquitoes and other biting insects away, but you basically can create like a barrier of high powered fans blowing around you. Like, have you ever gone into a supermarket where you get this blast of air and a curtain? Like, that kind of level of wind or fan will effectively repel mosquitoes, but you got to get the whole area surrounded.
Electric bills go up in Newton. Um, let's give the mosquitoes their moment. Are they important pollinators for blueberries and other plants?
Not blueberries. Blueberries are bumblebee pollinated and bee
And black
pollinated.
flies.
Black flies pollinate blueberries?
Yeah, yeah,
Oh, I didn't know that. Holy cow.
yeah. I studied those back in the day, back in the 90s. I was studying those, and so there's a professor up in Canada who decided to study it because they're the right size to go in there, and they have a lot of blueberries up there in Canada, and they found that they actually did pollinate them, and yeah. So
I,
I've never heard of mosquitoes doing that though.
I will typically see mosquitoes nectaring on flowers that have deep corollas, and typically flowers that are more upright versus hanging like blueberry flowers do.
Yeah, yeah.
Um, and I've seen them feeding on composites, so like daisy family flowers. Again, they typically have like an aggregate of tubular flowers where they feed like this, but like very small flowers.
Okay.
But I don't have all the information on that. Now I'm like, black flies pollinate. That's so cool.
It's bizarre.
Black flies have a purpose now, other than
They
making
always
my
had
life
some purpose. I
miserable.
mean, I know some people who think black flies are great because they keep people out of areas that are really nice, which I kind of fall into that category.
Okay, we're going to ask, we got one last category to ask. I'm afraid we're going to be cut off here. There seems to be concern about the use of pesticides and how it affects other creatures like birds. Alice asked, when walking my dog, should I try to keep him off the grass in yards with signs for tick and mosquito control? So birds and dogs. And
That is a big question. So I'm not sure how to come at it. I will say that larvicides, mosquito larvicides tend to be fairly targeted. So they don't have a lot of non-target action. Adulticides are not targeted. So in general, they're going to kill anything that's out. But the way that we get around that is by changing the size of the droplets that get sprayed. So if you can use what they call an ultra low volume spray equipment, if you could just put a very tiny droplet that's more matching the size of a small mosquito, then it's not going to have as big of an impact on larger insects. So I'm not going to sit here and say like, we only kill mosquitoes. Like, yeah, it's true that other things that are out flying at night are possibly going to get impacted if they're around the same size. Um, but I will say also that, you know, part of the way this works is that insects produce lots and lots of offspring compared to humans and other big animals. And so somehow, no matter how much mosquito control we do, there's always plenty of mosquitoes left over and are there the next year. So typically I'm gonna stop after this and just let Doug say something that will probably be much wiser
No,
sounding.
I wouldn't say that
But
at all.
but I guess I just want to say that like we're we're not trying to eradicate mosquitoes. We're trying to knock back high populations of mosquitoes. So we're coming in to do like in a way temporary controls when we do adulticiding. And it doesn't tend to have a significant long-term impact on insect life. That's just about insects. Um, when someone asks a question like that about their dog, I would say that in general, these insecticides are not going to have an impact on dogs. And if you're doing flea and tick treatments on your dog, you're probably applying very similar chemicals in a lot of cases, but you don't generally know what product was applied when someone has a sign on their property. So if it were me, if I didn't know exactly what it treated with, I wouldn't want my pets on it. And those people probably don't want your pets on their lawn anyway. So maybe it just works out better. I don't know.
Oh,
All
you're
right, I'm done.
That's kind of what I was thinking is I would think if someone has like a sign like that, they're most likely not treating for mosquitoes, they're more likely to be treating for ticks, I would think. Um, and that is more of a problem, I would think, for because that is something that's got a residual. It's meant to stay there for a while, and it's not going to break down very quickly. It's meant as a kind of typically like a barrier treatment. So they'll be putting those on places like grasses, or maybe if there's some shrubbery separating the forest from the kind of play area or whatever that the people use, they might spray those areas so that anything that comes in contact with them is going to die. And so those are the areas that I would be most concerned with, to be honest, if it was a dog or something of that nature, because um, yeah, that it's meant to stay there for a while and be effective for a while. Um, so I would be more worried about those products.
Yeah,
Um,
that's true. I mean, I just want to be careful. Like these products are typically labeled as being safe for human and other animals. It's just that when you don't know what's being applied, then
or
how
how
do you know
much.
it's one of the safe products? It could be one of those. I don't know a lot about some of the like organic treatments that are out now, so I can't say whether they're safe or not just off the top of my head. I guess I would look it up before I took my animal somewhere, I guess, but I don't know. My animals eat stupid things all the time. So this is like the least of my problems with my dog. So,
Well, thank you. As one attendee said, excellent show, surprisingly complex and fascinating. And that is really true. Thank you for giving us so much information. And if you have more questions, I have a few more questions, but you may submit them to Jennifer and Doug through webinars@newtonconservators.org. We really thank everyone for joining us, for learning about mosquitoes in our community. And most of all, thank you so much, Doug and Jennifer. That was really just an amazing program. Night, everyone.